All right, let's finish up these notes here by doing some a little bit trickier integrals, and let's see what happens here. So it says find each of the following definite integrals applying the fundamental theorem of calculus. Show your work, then use your graphing calculator to verify your results. All righty, so let's dive right in. So the first thing we've got to do is we have to find the antiderivative of the given function so that we can plug in our upper and lower bounds to that antiderivative. So this is a polynomial function, and the antiderivative here, we're going to increase our exponent by 1. So our first becomes x squared. Divide the leading term by the new exponent. So that's just 1x squared. Minus, we increase our exponent by 1. That becomes x cubed. We divide our leading coefficient by the new exponent of 3. So negative 1/3 x cubed. Evaluated from negative 1 to 2. I'd like you to be very conscientious of your notation, making sure that when you take the antiderivative, that's when you drop the integral sign. And making sure that you indicate the bounds that you're evaluating this on. So as these problems get more and more complex, it's going to be important that we really keep track of what we're doing. Now that we found the antiderivative, we can apply the fundamental theorem of calculus by plugging in the upper bound, which is 2, minus the lower bound, and simplifying. So we don't need a calculator. We can handle fractions. So 2 squared is 4. 2 cubed is 8. Minus 1. And that'll be plus 1/3. Okay, I'm going to get some common denominators here. So 4, if I did multiply it by 3 over 3, that's 12/3. 1, 3 over 3. Okay. So 12/3 minus 8/3 is 4/3. Minus 4/3, that's 0. Cool deal. All right, so having an integral of 0 indicates that there's the same amount of area above the x-axis as below. Keep in mind, if you want to double check any of these as you go, then just follow the steps that we did in the last video. They're right. Oh, no, I didn't mean to do that. They're right here. Okay, to check these integrals as you go. You must show the longhand way, though, because we are not always going to be allowed to have a calculator, and you've got to be able to do this by hand as well. All right, let's try another one. This second question is kind of a trick question because we're on the interval from -2 to 3. And if I look at my function, there's an issue with this function on that integral that breaks the fundamental theorem of calculus. So I'd like, in class, I would have had you guys think about this and talk about it. So maybe pause the video and try to see if you can come up with the issue that this one has. All right, so maybe you came up with it, maybe you didn't, but the issue that this one has is that it's not continuous on the interval -2 to 3. So our fundamental theorem of calculus says that in order to apply it, f of x has to be continuous. Well, this function is not continuous at 0 because that would create an asymptote. So we're going to say f of x equals 1 over x squared plus x is not continuous. So the fundamental theorem of calculus does not apply. All right, that was an exciting one. Okay, now we get to move on. This next one, we've got a fraction. So right now, the only thing that you guys know how to take the antiderivative of are things in polynomial. You might not want to write this down, but polynomial form, sine, cosine. Okay, those are the main things that those are the only things we found the antiderivative of. So what we don't have is some type of like backwards quotient rule. Okay, so we don't have that yet. So we need to rewrite this into polynomial form. So I'm not ready to take the antiderivative yet. So I'm going to keep my integral sign. I'm going to divide both terms by x squared. So whenever I do 2x divided by x squared, that becomes 2x to the -1. Plus, when I divide 3 by x squared, that's 3x to the -2. Now that it's in polynomial form, we're ready to take the antiderivative of it. So this piece was the interesting one. So whenever you try to increase your exponent by 1, you end up getting x to the 0. And then when you do 2 divided by 0, well, that breaks math. So that's not going to work. So this is the case where we have the natural log. So the antiderivative of 2x to the negative 1 is 2 natural log of x. Anytime you're doing the antiderivative, you can always check this by taking the derivative of it. So I'll just kind of do that off to the side real quick. So the constant 2 would stay in the front. We do the derivative of the inside function. So the derivative of x is 1 over the inside function x. Well, that's 2 over x. So that's what we started with. So that's good. All right. Then our second term, let's see, increase our exponent by 1. So that'll be x to the negative 1. 3 divided by negative 1 is negative 3. We're going to evaluate this from 1 to 4. Before I evaluate this, I'm just going to rewrite that negative exponent as 3 over x instead, just so it's a little easier to look at. And now I'm ready to plug in my values. So I'm going to plug in the 4. Minus, and then plug in the 1. All right, so 2 natural log of 4. That stays. Oh, I forgot my absolute value signs again. In this case, it won't matter on the natural log because 4 is already positive and so is 1. But that could make a difference if they were negative. So remember, the antiderivative of 2x to the negative 1 is the natural log of the absolute value of x. We can drop the absolute value in this last step here because 4 is already positive. All right, the natural log of 1, that's e to what power is 1? So that's 0. So this is 0. So that's just negative 3. So 2 natural log of 4, and then we get negative 3/4 plus 3. That would be a positive 9/4. Okay, you can definitely double check that on the calculator. All right, last one. Ooh, we've got a cosine. That's fun. Let's see how we can handle this. It's already in polynomial form, so I'm ready to take the antiderivative. So the antiderivative of 2x, well, I increase my exponent by 1, and then I don't need a coefficient because that 2 would drop down and make the 2x, so we're good to go there. The antiderivative of cosine is sine, evaluated from 0 to pi. So I'm going to start by plugging in pi. Minus, I'm going to plug in 0. And simplify this. So pi squared. Sine of pi is 0. Sine of 0 is 0. 0 squared is 0. So our answer is pi squared. Yay! So key steps here. When you're asked to evaluate an integral by hand, you need to find the antiderivative of the function that was given. And then you're going to use the fundamental theorem of calculus. You're going to plug in the upper bound and the lower bound, subtract them to get your answer. All right, the AP exam loves table questions, so I like to throw these in wherever I can. It says, pictured below is a table of values that shows the values of a function f of x and its first and second derivative for selected values of x. Use this information in the table to answer the questions that follow. So let's just make a little, I'm going to go down below here, make a little side note. So we have our original function f of x, and in previous units, we took the derivative and we took the second derivative for that function. So if you want to go from a function to its first derivative, you take the derivative. Okay? Now, what we're doing now is we're going back to what we're calling the antiderivative. So if you want to go this direction, this is taking the antiderivative. Okay? So we have to think about like what functions one away and which direction we need to go. So this says, what is the value of, and the integral from -3 to 1 of the derivative of f of x. So I'm going to write the question. F prime of x dx. So the fundamental theorem of calculus says in order to figure this out, we have to do the antiderivative of this function. So we're sitting with the first derivative. So the antiderivative is to move in the table up the table this direction. And so the antiderivative will be the original function. evaluated from -3 to 1. So we'll just do f of 1 minus f of -3 and find those values in the table. So that's -6. Okay, it's really important to keep track of which way we're moving in the table on these, or in our little list. All right, let's find this one. So this technically should have parentheses. They were accidentally left off. So we're going to find the antiderivative. So the antiderivative of the derivative we said was the function. And the antiderivative of the second derivative, move up the table, will be the first derivative. We're going to plug in 3 and subtract, plugging in -1. F of 3 is 1. F prime of 3 is 3. F of -1 is 0, and f prime of -1 is 1. So I get 4 minus 1, which is 3. Alrighty. If you have any questions at all, please reach out to me via email, and I'll either set up a Google Meet to help you out or help you out by email, whatever works best for you. I hope you guys have a great rest of your day.